Okay, somebody will tell me on Slack if I improved the humming. Yeah, can somebody tell me if I've improved the humming? Did that improve it? Okay, great. Ironically, that was actually nature. I live out in the country, and that was more silent but still present. I don't know what it could be. Fuzz type noise distortion. Let me see if. Let me try one other thing. Hey, does this help? Does that help? Oops. Does that help? That probably. Okay. Hey, does this help by any chance? Am I testing? Is that better? Is that better? The most amazing invention on Star Trek. Maybe the mic is not grounded. The mic is a lavalier that's plugged into my computer directly. No, that did not help. Okay, I tried setting the mic down just a little because it was clipping. Testing, 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 testing. I don't hear an overwhelming static, but voice is fuzzy. Well, my line is also not great. Yeah, it's okay. Look, guys, I think this is as good as it's going to get. I suspect the root cause of this is my crummy internet line. If it becomes a completely unworkable, I will figure something out and reschedule. Yeah, Star Trek. I always thought the communicator was the most science fiction thing in Star Trek. That people would flip open the communications device and start talking and not hear. Start with, "Can you hear me?" Okay, cool. It's better now. All right. Yeah, I'm almost certain it's related to my internet rate because people are telling me it's better when the rate goes up. Okay. This is this is our big week. This is the week we do SLB Resolution. And I know I've been very slow getting into this point, but that's because I wanted everybody to be well prepped for it. And honestly, once you're well prepped for it, this material's not that bad. SLB Resolution is the mechanism Prolog uses to do proofs. It stands for Selective Linear Resolution with Definite Clauses. If you're panicked, we're not going to go into what SLB Resolution is. I've managed to do most of my Prolog programming with only a fuzzy idea. So, okay, Prolog is a dual paradigm language. One way is to understand it as searching for proofs. But another way of understanding it is as an imperative language. And the way you can do that is that the proof search algorithm is actually simple enough that you can understand it and read about it. And that's why it's important that we learn this algorithm. It's because if you're going to think about how Prolog works, you're going to think about the SLB algorithm. Does everybody know what a paradigm is for a language? A paradigm is a model of computation. Java's model of computation is messages between objects and imperative programming, that is, giving the computer instructions between in the bodies of those the methods on those objects. Haskell models computation as evaluation of functions, including meta evaluation. Prolog is dual paradigm. In one respect, you can see it as searching for a proof. The other way is you can just see it as giving instructions to the computer. All right? Questions before I go on? Speak now or? All right. Every programming language has a execution order. What to do if nothing else happens? Python is read from the top to the bottom. So is Lisp and Clojure. Nope. Oh, I take it that's nope. I forgot about the 10-second delay. So, okay. Prolog runs like a two-stroke engine. We start out with a goal, and then we do unify stroke, resolve stroke, until either you get back to where you have proven your initial goal or you fail. So, the important stroke is the unification stroke. It's the one that can be hard for people to reason about. And that is, when you have a program, you should take the goal you are trying to solve. You will have a stack of goals, and you can at least imagine that those goals, some of them are a list of things. They're actually what's called a round list, if the body has commas in it. But you take your topmost, you take the top of the stack, the leftmost item, that's the top of the stack. You look downwards through your program until you find a fact or rule. I'm just going to call them all rules. Until you find a rule that matches, that unifies, that is a possible solution to your query. Let's try this. I'm going to use a family tree, which you probably have already seen in Clarkson and Mellish. Here we go. So if you want to follow along, I've put this in the students folder on Google Docs. This is Annie's redneck family tree. So let's find out who is male. What I'm doing here is I'm asking the system to prove that there exists a solution to male for some value of x. It uses proof by construction, if you remember from the Garden of Proofs. It says, yes, x could be Dawn. It then waits. If I type semicolon, it is going to backtrack. And when it found this, it left a note to itself that there are other possible choices for male. So we're going to get other choices. Okay, let's go through that in a little more detail. I make this query. It goes onto the stack. We then look downwards through the program. None of these can match because we are looking for a head with functor male. At this point, we now have something with functor male, and in order to unify, it must have the same number of arguments. So the same number of arguments, 1 and 1, so that's a possibility. Can the arguments be unified themselves? Dawn unifies with x because x could be anything, and so we get a solution. It's not the only choice, so we leave a choice point and we come back. Is this clear to folks? Is this making sense? Am I completely unintelligible? Has the sound dropped out? Oh, there's a 10-second delay. Is there a 10-second delay? Okay. Yay, okay, great, great. Yes. So what's going to happen if I, for example, so that's the unification stroke, and unification is actually pretty simple. This is the same material. I'm basically going over material covered in Chapter 2. Yes. This is unification. Now, why would we use unification? Suppose we were trying to design a search engine or a proof engine. Well, we only want to examine things that might be a solution. What might be a solution? Well, things that are male 1. Nothing else can be a solution. Paradigm is not relevant to us. Grandfather and brother and us, all this stuff is not relevant to us. Only the males. And only those with one argument. If we had if we had some more complicated definition of gender, for example, we could have a male too, in which we say that a person is male socially, that is, or they're a man, or we could say they're chromosomally male, or physically, anatomically. So, this is your video hangs. Well, I'm sorry, there really is, there's a video engineer in the class. I'm going to hit him up to see what I can do about this, but this is about as good as it's going to get, I think. What would be the search space for X when unifying male X? The search space would be everything in the program when we start. Of course, we're immediately going to discard everything except for the facts about who's male. So the search space is going to be all of the clauses for male. Okay. I'm going to give a 10-second pause to get questions. Not hearing anything, so I am going. Now, there are a couple of things that go on. When we, and actually I'm going to go back to this for a moment, and one other thing's got to happen here. What would be the cost of reducing the set male? Well, very little, actually. Prolog, when Prolog consults, the last thing it does is it takes the new predicates that it has defined, and it produces an index, much like a database index. And that database index is extremely read-oriented. So it's very, what would say, heavily indexed. The Prolog indexer is extremely efficient, and every time you call a system predicate, every time it goes through this cycle, it's going to find the appropriate thing. So so making that smaller is not actually very, it doesn't buy you much. If you have thousands of arguments and those arguments are deeply nested structures, then you begin to run into questions about how efficient the indexer is. But for most things, this happens extremely efficiently. The Prolog indexer is one of the most carefully tuned queries on Earth. So, okay, so I'm going to return here. Yes, it knows that there is more than one male when it encounters the first. The index, it has an index of all of the male one predicates, and even has an index that will let you figure out, suppose I call male with Dawn and just want to find out if Dawn is male, then it will actually, the indexer will only return the male Dawn one, and it won't make choice points. You can tell what the indexer did by essentially whether it left a choice point, and I'm quite certain that it knows that Dawn is male. So let's try this. Let's find out if Dawn is male. Yes, and notice no choice point. That's because it knows it'll never succeed with the other ones. Is this making sense? Okay. Okay, cool. What if we can't find one? If we can't find one, then we we look up the last choice point. We reset the computation to that point, and we take the next choice. And that's what failure does. Norbert says just that it can only have an index about simple relations again. That's like atoms. No, that's not true. Actually, the indexer is quite good at things like at things that are quite deep and complex. And basically, like I say, if it finds it with the indexer, it'll know not to have a choice point. So you could try making some kind of complicated, weird rule and or fact, and then asking whether it's going to unify. Let's try a little experiment here. One way of making a complicated, weird fact, let's make a list. I will make foo of some list 1, 2, 3, 4, 5, 17, 7, 8. And then I'll make some different numbers. If the Niall has asked, missed something in the audio, being heavily nested is the word. I am currently demonstrating that even though it's fairly heavily nested, sorry, I forgot to compile this. Let's try that again. Now, if you think about this, a list is actually a linked list. So this is a structure that is 8 elements deep. And it's a big nested structure. And yet, Prolog was smart enough that it knew that there was only one case that matched it. So, the indexer is indeed awesome, and let me tell you, I am not going to end up, is it not, Tomer, no, that's not true. Is it true that there are men in my family? Somebody want to try and prove that there are men in my family? In the chat? D.B. Burkle, yes. Yes, Don is a man in my family. And this is proof by construction. But we might know, right, there are more. And the reason we want it to work that way is that we might only want men whose names start with D. Connor, for one thing, we might want to know how many proofs there are. That's a rather academic use. More importantly, yes, we might want to know the name, all of the different solutions. That is, the only reason we're asking if male can be proved true, that is, if there are men in my family, is so we get the names. Suppose I'm kind of interrogating someone who's being a little uncooperative. Imagine I might claim there are no men in their family. It's a bizarre claim, but you know, I claim that there are no men in their family, and they say, huh, Don's a man in my family, and I now have a piece of information. I have one name of a man in their family. So Tomer, what's being indexed is the entirety of the clause, not just male. No, Corey, you're trying to use predicates as functions, and that doesn't really work. You instead want to say that, I'm not certain what has men means. Men in family. You don't need all of, yeah, you just, you need ancestor, which is actually, I think I wrote that at the bottom. If you use ancestor, it kind of gets rid of the excess stuff. Yeah, men in Annie's family. So that would be Anne. We know we need some related to. We need basically not even ancestor, but we need related to. Now, that for me is just ancestor because I don't have children. So, so who would be a man? What's it mean to be a man in my family? Well, yes, of course, there will be no, Tomer, yes, there will be no choice point if you only have one choice. There are no more choices. If you add a second male to the database, you'll of course have a choice point. And in fact, it will not then give you a choice point after that second one. It will just stop. So indexing, if there was no indexing, you would have to look through the entire knowledge base to try and find the next thing to unify. Could you write men and family related to? No, you cannot, Corey. You are still trying to make function calls, and there are no function calls here. And in fact, so Corey, what you're asking is whether the compound term male sub x is related to Annie. And no, it's not. I have no compound terms in my family. I've got a couple of mangy dogs and can developers develop a choice point? Of course you could have a choice point. You'll make choice points all the time. Developers, I have made choice points here. I mean, choice points are a runtime thing, but yes, male for this program will have choice points because I've listed many males. Corey, isn't male a functor? So male sub x is a deconstruction. Don't know what a deconstruction is. Male is a functor. Male sub x is a compound term. It also happens to be male 1 is a predicate. This is why I did all of that stuff on the syntax kind of ahead of time, is that I often find that getting your vocabulary right helps you think about this stuff. So there is no such thing as deconstruction. I'm not certain what that is. Sorry, I'm being a little hard on you. And Norbert, yes, you can control the order. You can control what order things are in the file. So, yeah, Prolog does not have the notion of return. Instead, to get information to go up in the stack, you use unification of arguments. Variables that aren't bound on entry are effectively pass by reference. Okay. I see you're continuing to ask questions. I'm going to go on a bit, but I love the questions, so keep them coming. Okay. What if we reach the end of the things we have to prove for this to be true? Then we pop the stack frame. What if we're out of stuff? We pop the stack frame, and the first thing is now proved, and we in the superior stack frame, and we can continue on. Okay. Related to is expecting an atom. Yeah, right. The only things that anybody yes. Nope, you're right that the only thing we're passing around here is atoms. I am not related to the number 3, the dictionary that contains my, the DIC structure that contains my employer records for 1987, the body of HTTP GET or mail sub X. I am related to Dawn, right? Even if I want to say, all men are my brothers, then I would say that brother X Annie is true. I just make it a fact, and or just insist that X is male, and but X I would still expect to be an atom. Yeah. People's names in this are atoms. If you want to be a little philosophical, I'd point out that I am not related to the word Mike or the sequence of letters M-I-K-E. I am related to an insurance adjuster in Kansas named Mike Ogborn. He's my brother. But we use names to represent people, understanding we're usually referring to the person. And if I really want to refer to my name, then I say, my name is Ann Ogborn. Yes. Related to expects the atom. Okay? And anybody else confused by that one? It's a very, I suspect what you're doing at some level is kind of expecting arguments to be evaluated, and they aren't. Okay, the other stroke is actually simpler. The other stroke is as simple as make a new stack frame, and then you've already unified the variables in the head, so that's going to unify some variables in the body, because all those are going to share. And then, so you take that and you shove it on the, shove it in as a new stack frame, and go back to the unification step, start with the first thing, and we keep pumping. So the resolution step is actually fairly simple. There are a few things to cover in it. And yell at me if this is being confusing. But, okay, here I have foo, which requires bar, baz, and bort. So exactly how does this happen? Well, comma actually is just the and, it's seen as and it associates. God, I can never remember, is it associates left or associates right? I guess it associates right. So, so here we, here is what the SLD algorithm is actually seeing, which means that basically every predicate, every rule that has more than one thing in the body is just going to be seen as an and just calls the first thing, and then if that succeeds, it calls the second thing. So so that's pretty much how commons work. There is an operator, the right arrow, the so-called soft cut or if operator. It pretty much does the same thing. It just evaluates the arguments. Okay. Everybody good? This is the hammer story. Sally goes into a hardware store and says, I'm pounding in fence posts and I need a really big hammer. And the guy behind the counter says, hang on. He pulls out a small hammer, and she says, no, I need a bigger hammer than that. So he puts that one back and gets a bigger hammer, kind of a hand sledge. She said, no, I'm pounding fence posts. I need a big two-handed, like, sledgehammer things. A big hammer. He says, oh, okay, well, hang on. I think I have one in the back. So he goes in the back, rummages around a while, comes back out, he doesn't have a hammer. He says, sorry, I must have sold it. I've shown you the biggest hammer we've got. So Sally leaves without her hammer. What's the hammer story mean? Well, Sally has asked the hardware store guy to prove that he has a hammer. And he proves he has a small hammer, he proves another hammer, but none of them are acceptable to Sally. And then finally he goes in he says, I have another choice point. He offers to make another choice. And he goes in the back and he doesn't have it. Just because he said, I think I have another one, doesn't mean he's actually going to produce one, right? Prolog does the same thing. You will be left with a choice point, and then that choice point, when you return to it, will fail. So that's the hammer story. Okay, questions about the hammer story? Okay. I think people seem to be good. All right. There is one predicate. It is named exclamation point and called the cut. that performs commitment. You might date somebody once or twice. Think about having a relationship. Maybe even go out, study for a month or two. But at some point, the question of marriage comes up, and marriage involves commitment. If you get committed, your other options are closed. So, when you, and this is actually something we want in many situations. The example I've been using a lot is car keys. I lost my car keys. They're not in my purse. So I kind of make a mental list. I check my nightstand, and no, they're not there. And I check the kitchen, and they're not there. And I was working on something in the garage, and they're not in the garage. And I find them in the car. I, had them in the ignition. I pulled them out of the ignition, left them on the seat while I picked up some bags and forgot them. Right? Fine. I now have my car keys. Am I going to continue to look for my car keys? No. And in fact, what can you tell me about my pants in the wash? Yeah, what can you tell me about my pants in the wash? Waiting through the little delay. People are typing. Yes, Corey is right. My car keys are not in my pants because they're now in my hand because I found them in my car. And so I know where my car keys are. So I don't have to search in my pants. And in fact, I might not want to continue on and get other things that might be offered as solutions if I realize, oh, I've already found them, right? So, this is the common case of having some general method of, suppose you have a desk work job, and you've been instructed that when Form 47 is filed, you're required to have such and such and such and such forms. And then people will say, except when the person is coming from a country that is deemed to have a at-risk government, and then we don't ask for those forms. Fine. The way you do that in Prolog is you say, hey, are they from an at-risk government? Okay, they are. Then we're going to use this rule, and the other rules don't apply. But then we don't have to mention that in the other rules. right? Otherwise, we would have to always say, and the person is not from an at-risk country, and that would get very cumbersome very quick. Okay. All right. Are there more questions about SLB resolution? I tell you what, I am going to terminate the broadcast just a little early, and I'll see you on the Slack because it's faster.